Okay, this is the second part of the marathon on differential equations. If you've not watched the first part, I strongly recommend that you go on and watch that. We discuss a few things there that will carry on into this part as well. So, beginning with this question that we have here. This is a relatively challenging question, and what I would suggest is that you look at it carefully. It gets more complicated as you move on and try to solve this 8 mark part. First, it says the tank contains water in the form of a hemisphere. The sphere axis is vertical, the lowest point is A, and the radius is R, as shown in the diagram. The depth of the water at time t is h. At time t equals to 0, the tank is full, and the depth of the water is R. So that's something that I need to be aware of. That when time is 0, R is equals to H basically. So it's the same as the radius is the height basically, because it's a hemisphere. At this instant, the tap at A is open and the water begins to flow out at a rate proportional to root H. The tank becomes empty at time t equals to 14. So it's losing water. So it's going to be negative. That's what I need to be aware of as well. The volume of the water in the tank when the depth is this is given by this formula. I think it's going to be easier if I have this multiplied out, 3 pi r h square over 3. That sort of gets rid of the 3 in one of the numbers as well, and that is something that I might find useful later on as I go on. So I've cancelled out the 3 by expanding it first, and I'm going to find it easier to differentiate it as well. I can then take a common later on if the question requires me. It says show that h and t satisfy the differential equation. So I'm talking about again rate of change. What I know is that this tank is losing water and water begins to flow out. So the outflow of water is dv over dt, and that is given as proportional to root h. I'm going to say minus k root h because it's losing water. That's something also that you need to be aware of. The tank becomes empty at t equals to 14, so volume goes down to 0, and h also becomes 0 when I reach time equals to 14. So let's try to first construct the chain rule here only. I'm going to say that I'm going to need dv over dh, and that is going to break down into dv over dt and dh over dt. So let's see if we can get dv over dh from our expression on volume that the question has already provided. So pi r h square, that's what I've simplified. So that's what I'm writing down, pi h cube over 3. So let's differentiate that. I get dv over dh equals to 2 pi r h minus 3 pi h square over 3. I hope I'm not making a mistake. Okay, so that's dv over dh for me. Now putting these into a chain rule, 2 pi r h minus pi h square, dv over dt is minus k root h, and dh over dt is what I need. So what I notice is there's a b here, and the rate of proportionality that I've used is k, which is generally true. This is where b is a positive constant. So b can comprise of a number of a complicated expression as well, as long as the number boils down to a positive constant. It needs to be made up of constants, not variables. That's one thing that you need to know. And it could be anything. It could be a combination of numbers and constants, unknown constants, whatever the case may be. Let's try to then come up with this expression. I'm going to rewrite this expression so that I can then solve it. Dh over dt minus k root h over 2 pi r h and pi h square in the denominator. Now what I notice is there's no variable here, and this is just a positive constant. So I need to somehow move this root h into the denominator. Now the easy way of thinking about this is that I can say that dh over dt, if I were to take this, and if you notice there's a minus here, I can take this minus and put it outside here, so that gets rid of that. If I take that other root h down, can I say that it becomes h power minus half because it's in the denominator? Now this h power minus half, it's going to get multiplied with both the terms. So I'm going to say that this is basically 2 pi r h power 1 minus half, that gives me half, and h power 2 half minus half, that gives me 3 over 2. So I think I have the expression that I wanted in the denominator. The only thing that is problematic here is there's a pi present. So what I'm going to do is I'm going to take a pi common, and I'm going to say that it looks like this: k over pi divided by 2 r h power half minus h power 3 over 2. So I've taken pi into the numerator. So that sort of gives me the expression that I wanted. The only point of contention that you may have is that there's a b here and there's a k over pi. So that's what the question is saying. P is a positive constant. I know that k itself will be a positive number because I put a negative outside when I was doing the proportionality, and pi is automatically a positive number. So that's something that is very clear. Okay, so I have this expression. This is proven. There's nothing else to be done in this part. Part B is then more challenging. It says solve the differential equation and obtain an expression for t in terms of h and r. So I'm going to start doing that. I'm going to say that I need to integrate. Now, even if I was unable to prove, I have the expression from here. I really don't need to worry about anything else. It's going to automatically boil down and give me the right answer, even if I've not done part 1 correctly. It's simple. I can move 2r h power half and h power 3 over 2 here, and that's dh and minus b and dt. Let's integrate that. That gives me 3 over 2 divided by 3 over 2. H power 5 over 2 divided by 5 over 2. I'm integrating them. Minus bt plus c. Two unknowns, therefore I should have two sets of information. One of the sets of information is one that's given right at the start, so that's what I figured out when time was 0. R was h. Why? Because the entire thing was full. So I'm going to write 2 r r is constant, right? So what I'm going to do is, what I should do is height equals to, because height is the variable, r is not the variable, so height equals to r. So I'm going to write r power 3 over 2 over 3 over 2, r power 5 over 2 over 5 over 2 minus b into 0 plus c. So this gives me 2r power 5 over 2, and if I multiply this becomes 2 over 3, 2 over 5, and there's another power 5 over 2. So that gives me c actually, and that's what I was looking for. This becomes 4 over 3 minus 2 over 5. So let's do 4 over 3 minus 0.4. It gives me 14 over 15. If I'm doing this correctly, 14 over 15, r power 5 over 2. Now remember that r is a constant because it's the radius of the bowl. That's not changing. It's the height that's changing. So that's something that you need to be aware of. Then taking this to the next page, 2r h power 3 over 2 over 3 over 2 minus h power 5 over 2 over 5 over 2 minus bt equals to minus bt plus 14 over 15 power r power 5 over 2. Now the other set of information that I have is from here, that when v equals to 0, h equals to 0, and that's time 14. That's what I'm going to do. So r remains as it is, height goes down to 0, so that makes this 0, this makes also this 0, and time is 14 plus 14 over 15 r power 5 over 2. So that gives me 14b 5 over 2. So b is r power 5 over 2 divided by 15. So that's encouraging. I seem to be getting through to my answers. I have both c and b, so I'm going to replace that. Now I'm going to also simplify this fraction. Let's write 4 over 3, 2 over 5 r power 5 over 2 over 15t plus 14 over 15 r power 5 over 2. Now what do I need to make the subject? I need t in terms of h and r, so I need to move the r terms on this side. There are two ways of doing that. No, you see, you're not bound by what is appearing in the answer. You can just simply take this term to the other side and then divide divide this on the other side, and you can get an expression that's going to be perfectly fine. What I'm going to do is I'm going to try to generate the expression that's there up in the marking scheme. So I'm going to say that first this becomes 15, this becomes 20 r h power 3 over 2 minus 6 h power 5 over 2 equals to, let's take an r power 5 over 2 common, and there's a 15 common as well. And I'm also going to take a minus common so that this term becomes positive. This becomes t minus 14. So this cancels out with that. And this gets divided. This is a minus, this becomes a plus. So I have 20, the powers for r get subtracted, r power 3 over 2 in the denominator and h power 3 over 2 in the numerator. And I can write this as h over r plus 5 over 2 t minus 14. So 14 comes to this side. I can also write this as h over r. So I have the exact same expression that's there in the marking scheme. So that should work out. If you had another expression, it would also have been perfectly fine. Moving quickly on to the next question. Now again, this is a tough one. Let's look at this carefully. It says in the diagram, the tangents to a curve at a general point P with coordinates x comma y meets the x-axis at t. The point N on the x-axis is such that Pn is perpendicular to the x-axis. So this is a vertical line, that's what I know. The coordinates of this are x comma y. This length is y because it's basically the y coordinate. Okay, then it says the curve is such that for all values of x in the interval, the area of the triangle PTN, so area of triangle, let's write that, area of triangle PTN is equal to tan x. That's interesting, where x is in radians, using the fact that the gradient of the curve at P is Pn over Tn. So I'm going to write that dy over dx is Pn over Tn. Okay, show that the differential equation. So dy by over dx is equals to Pn over Tn. I have to somehow convert it into half y square into cot x. That's weird, but I can see that Pn immediately goes to y, so the only thing that I need to replace is Tn. Now Tn is this horizontal length. It's not the x coordinate because the x coordinate is this is x, so you can't just replace it with an x. It's going to create trouble. So I come to this piece of information that I have here. Let's write that. If I were to write the area of the triangle, I would write it as Pn into Tn, half into base into height, equals to tan x. Now I know that Pn is y. Now I can see something emerging from here. Can I say that Tn is therefore 2 tan x over y? So that gives me 2 tan x over y in the denominator. So this becomes y squared over 2 tan x and ultimately becomes half y squared cot x. So that's the proof. That's the proof for this part. So just follow the information. It's going to automatically sort of give you hints. There's no other way to do it. But if you get confused, you can leave your calculations, go to the next part, do the differential equations, come back to it. Why? Because you see, if I've given you this, then you can simply go on and first solve. As long as you know your integration, you'll be able to get these 6 marks out of this question. And those will be the easier 6 marks, to be honest. Unlike in the previous question had some difficulties there as well. So moving y squared to this side, 1 over y squared dy, and let's also move 2 to this side, it makes it easier. I don't like dealing with fractions, so I sort of avoid that. It's your call though. See, it's relatively easy to do this. Okay, cot x, you have to remember the integration. Cot x can be integrated to make ln sine x. This is a derived formula from integration by recognition. If you don't already know that, please make sure that you revise this. And then I'm going to put a plus c. So minus 2 over y ln sine x plus c. What is y? Do I have a piece of information? It says y equals to 2 and x equals to pi over 6. Pi over 6. So ln sine pi over 6 is basically half. So ln half. So basically that can be written as minus ln 2. So c is basically ln 2 minus 1. I need y in terms of x, so minus 2 over y. Ln sine x plus ln 2 minus 1. So minus 2 over y. These two can be combined. Since I need one, I just need to make y the subject, so I can just say minus 2. I'm not looking at the answer right now. So that's the same answer that's there in the marking scheme as well. If you want to copy the exact answer, you just take the impact of the negative in the denominator, and that should work out as well. That's it for this question. Let's move on to this question. Again, a tough question. Let's quickly get through this. It says a tank containing water in the form of a cone with vertex C. The axis is vertical and the semi-vertical angle is 60 degrees as shown in the diagram. At time t0, the tank is full and the depth of the water is h. At this instant, a tap C is opened and the water begins to flow out. The volume of water in the tank decreases at a rate proportional to root h, where h is the depth of the water at time t. The tank becomes empty when t equals to 60. Show that h and t satisfy a differential equation in the form where a is a positive constant. Okay, again I have to go back, look at the information. The axis is vertical and the semi-vertical angle is this. At time t0, the tank is full and the depth of the water is capital H. So t equals to 0, h equals to capital H. It's a constant. At this instant, tap C is open and water begins to flow out. So what is flowing out? dV over dt proportional to root h minus k root h. The tank becomes empty when t equals to 60. Again, I have to find dH over dt, which means that I will have to somehow come up with the chain rule. Now, the difference with this question is there's some formula given for the volume. So you will have to come up with a formula yourself. So at any point, if I'm trying to find the volume of the water, it's in the shape of a cone. So I can say that I know the volume for the cone, which is 1/3 pi r square h. Now, I don't have the radius. And you see, I have to express the entire thing in h and t, which means that I can't have radius appearing in my formula. Somehow I have to get rid of the radius because that's changing as well. I cannot have three variables in my question. It's volume, radius, and height, but I just need volume and height. So what I'm going to try to do is I'm going to use some trigonometry and say that tan 60 is equals to r over h. So r is basically h tan 60. H tan 60. Now, tan 60 is simply root 3. Let me just verify that. Yes, it's root 3. So r is basically root 3h. At any point in time, r is basically root 3h. So again, I'm going to do dv over dh and say that this becomes 2 over 3. Let me just first replace r with root 3h. to h. So that becomes pi h square basically. So dv over dh is basically 2 pi h. That makes it very simple. Then I come up with the chain rule. dv over dt is minus k root h, and dh over dt is something that I'm trying to find. So I'm going to now take this to the next page. 2 pi h minus k root h and dh over dt. Okay, let's see what the difference in our proof and their proof is. There's h in the numerator, so what I'm going to have to do is I'm going to have to move everything to the numerator. I'm going to say that h power half minus 1 I seem to have made an error somewhere. Oh, there had to be a square, so that's h cubed. So that's h cubed. So that's 3 pi h square. It's a lot of errors. 3 pi h square. 3 pi h square. So that's 3 pi h squared. So minus k over 3 pi h power minus 3 over 2. That is my final answer. A is a positive constant again, so I'm going to let A remain as it is. We'll see what happens to it later on. Part 2 says solve the differential equation. So I'm going to move h to this side, and I'm going to say that this comes out as h power minus 3 over 2 dt. I'm going to let it remain as minus a. Let's see what happens later on. So that's th and that's dt. I bring it up to make it positive because I have to then integrate it. H power 5 over 2 divided by 5 over 2 equals to minus 80 plus c. So that's 2 over 5 h power 5 over 2. So integration was relatively simple. Let's see. And obtain an expression for t in terms of h and capital H. So when was capital H? When time was 0, h was capital H. So I'm going to say that 2 over 5 capital H power 5 over 2 equals to 0 plus c. So c is basically 2 over 5 h power 5 over 2. The tank becomes empty when time is 60. So I'm going to say that another pair of equations that I have is 2 power h power 5 over 2. Let me just write that again. Minus 2 over 5 capital H power 5 over 2 t plus c. So the tank becomes empty, which means that this height goes down to 0. That height was the initial height, so that remains as it is. And t was 60. I'm going to say that 60 appears here. 24. So c is basically minus 24 h power 5 over 2. Positive, in fact. I will move it to the other side and it becomes positive. Okay, then making what's the subject? It says and obtain an expression for t in terms of h and capital H. T has to be the subject. So 2 power 5 h power 5 over 2, 2 over 5 minus 2 over 5 h power capital H power 5 over 2 t plus 24 h power 5 over 2. So I should have let the LCM remain as it is, if that was possible. Cross multiplying gives me 2h power 5 over 2 minus 120 capital H power 5 over 2 equals to minus h over 2, h power 5 over 2 t, and then dividing it on the other side, so this becomes h over capital H power 5 over 2. This h power 5 over 2 gets cancelled out, so I'm left with minus 120 equals to minus t. So t is basically 120 minus 2 h power. There seems to be a mistake with 120. Let's go back and check that. We must have made a mistake somewhere. I seem to have made multiple mistakes. Let me just go back and check. H power 5 over 2 divided by h power 5 over 2 minus at plus c. So when t equals to 0, h equals to capital H, which gives me this, c equals to 2 over 5. Oh, my bad. I've done some very huge errors here. I didn't notice that. I've messed it up. Let me just go back and calculate that. I've replaced, instead of replacing it with C, I've replaced it with A, which made everything more complicated. Let me just do over that again so that we get the correct answer. So that's the first capital H and times 0. Then I have another pair which says that the tank is empty when small h is 0. So I'm going to say that that's the value of A, which is why everything is becoming very complicated. So that gives me 60A equals to 2 over 5. So that's A as 1 over 150. Okay, let's see if that works. No, that's T. H power 5 over 2 into T. So let's take a common denominator to get rid of the fractions. I hate fractions in these questions. So 30 into 3, 60, h power 5 over 2. I think we have the right answer now. It's more or less like the same question that I did before. There's a minus here. So that's 60 minus 60h. Okay, so that's the correct answer. You can go back and look at this question. Okay. Let's look at Let's see if this question has anything that's very complicated. It says a model for the height h meters of a certain type of tree at time t is years after the plant assumes that while the tree is growing, the rate of increase in height is proportional to 9 minus h k times 9 minus h power 1/3. It is given that t0 and this and that. Show that h and t satisfy the differential equations. That's simple. You can just replace it with 0.2 k 9 minus 1 power 1/3 and that gives you 2, so k divided 0.1. So that's your first part. Part 2 says solve the differential equations. That's relatively simple to solve as well. You bring 9 minus h power 1/3 to this side, you let 0.1 remain there, and you integrate and you get 0.1 t plus c 9 minus h power 1/3 minus 1/3 plus 1 divided by 2/3. So I brought it up and integrated it. It becomes 3/2 9 minus h power 2/3 0.1 t plus c. So h is 0 when h is 1 when t is 0. So again, using that, so c gives me 2 squared is 4 divided by 2 is 2, that's 6. I hope I'm doing that correctly. 8 power 2 divided by 3 into 3 divided by 2, yeah, 6. Let's see if we get the correct answer. I have a feeling there's some calculation. We'll know at time. So I get 2/3 9 minus h power 2/3 3 2's and equals to 0.1 t plus 6. Cross multiplying, that gives me 2/3 on that side multiplied by 2 and divided by 3. So 0.1 into 2 divided by 3 gives me 1/15 t plus 12 divided by 3 is 4. Then I have to take a power. So 9 minus h, if I replace the power here, I'm getting a sign error, which is a little problematic, which is what I've forgotten here. And that's something that you should have been careful about as well. So that's minus 2/3 minus 3 2's. So that gives me that, and c should be minus 6. So that's minus 6. And that's minus 4 then. There's a negative here as well. There's a negative here as well. So then I invert the signs. A small mistake can cost you a lot. You should also be able to figure out when you've made a mistake, when the answer doesn't seem to be emerging the way that you want it to be. So okay, then it says find the maximum height of the tree and the time taken to reach the height after planting. So maximum height is when the differential is 0, so dh over dt should be 0. Now you don't need to differentiate this, you already have dh over dt, so I can simply say that when I place this equals to 0, so this becomes 0.19 minus h powered 1/3. So 9 minus h powered 1/3 is therefore equals to 0. 9 minus h is therefore equals to 0, so h is 9. Find the maximum height of the tree. So 9 meters, that's what I found out, and the time it takes. So then I can find out the time. That's simple. I can use this equation. I don't need to use the final equation. I can just say that I'm using this equation for part 3. I'm going to say that this becomes 9 minus 9 power 2/3 equals to 4 minus t over 15. So 0 equals to 4 minus t over 15. I could have used the other equation as well and it would have given you the same answer. So t over 15 equals to 4, t equals to 60. That's how you find the maximum. Calculate the time taken to reach half the maximum height. So that's also simple. I don't need to do a lot of calculations here. I'm just going to say that half the maximum height is 4.5 power 2/3 equals to 4 minus t over 15. Now I'm going to have to calculate a little bit. Use my calculator to do that. Power 2/3, and then 4 minus answer multiplied by 15. So I get 19.11, and that is my final answer. Okay, that brings us to the end of this marathon. I hope this was productive. Please make sure to like and subscribe if you watched this video, and please make sure to press the bell icon for future updates as well. Thank you.